Imagine a universe where the tapestry of existence begins to unravel. You, a tiny observer in this grand cosmos, are suddenly aware that space, the very stage upon which all cosmic drama unfolds, is not eternal. Picture the stars, the galaxies, even time itself, tethered to a fabric that seems to fray at the edges. What if space is not just an empty void, but a dynamic entity capable of decay? This is not science fiction. It's a possibility that sends shivers down the spine of cosmologists. In this narrative, we will explore the implications of a decaying universe, a realm where the laws of physics might morph into something unrecognizable. As you settle in, prepare for a journey that blurs the line between reality and the unfathomable. What becomes of everything within once space itself starts to decay? Picture a time when physicists first stumbled upon the idea that space might not be as static as once thought. It was during the study of cosmic expansion that scientists like Edwin Hubble noticed galaxies speeding away from each other, hinting at a dynamic cosmos. Fast forward to the late 20th century, when researchers armed with cutting-edge technology began to question the very fabric of space. Could it be susceptible to decay? Dive into the stories of pivotal figures who dared to ask these audacious questions. Through their eyes, witness the birth of a theory that challenges the core of cosmology. The notion that space could decay is not just intriguing, it's terrifying. It challenges the very foundation of physics. If space can decay, what happens to time, gravity, or the basic forces that govern the universe? This concept rattles the cages of scientific understanding. Contradicting the long-held belief of an eternal, unchanging cosmos, the implications are vast and unsettling. As you delve deeper, understand why such a theory was initially met with skepticism and disbelief. It's a paradigm shift that threatens to rewrite the rules of reality. Driven by curiosity and the need to understand, scientists embarked on deeper investigations. They deployed telescopes, satellites, and particle detectors in search of data. What they found were anomalies and patterns that suggested something was amiss. Cosmic microwave background radiation, the remnants of the Big Bang, began to reveal secrets. As the data poured in, new layers of mystery surfaced. What do these cosmic fingerprints tell us about the nature of space and its potential for decay? As the mystery unfolds, it becomes more complex and daunting. Evidence suggests that this decay might not be a slow process, but an accelerating one. Imagine a universe where the decay of space could potentially lead to catastrophic cosmological events, challenging everything we know. This is not just a theoretical exercise, it's a scenario that poses a genuine threat to the fabric of physics as we know it. The universe, once thought to be predictable, now seems like a fragile construct on the brink of transformation. To make sense of this cosmic conundrum, scientists have proposed several theories. Dark energy, the mysterious force driving the universe's accelerated expansion, might be a clue. Some speculate about false vacuum decay, where a quantum fluctuation could trigger a new phase of the universe. Others ponder the role of quantum fields and multiverse theory. Each model provides a unique lens, suggesting different outcomes for our universe. Dive into these theories and explore what each might mean for the cosmos and your place within it. The quest to understand this phenomenon is ongoing. Scientists are using an array of tools, from the Large Hadron Collider to space missions like the James Webb Space Telescope. They are striving to measure, prove, and perhaps predict the behavior of a decaying space. What are the latest findings? How are physicists attempting to map this uncharted territory? Join us as we explore the cutting-edge science that seeks to unravel one of the universe's deepest mysteries. As we close this journey, reflect on the profound implications of a decaying universe. What does it mean for humanity if the cosmic stage itself is impermanent? This mystery challenges our understanding of reality, life, and time. It invites us to ponder our significance in a universe that might be more transient than we ever imagined. What questions remain unanswered, and how does this mystery push the boundaries of human knowledge? As you ponder these reflections, consider how this cosmic enigma reshapes the narrative of existence itself. Picture yourself peering through the lens of a telescope, one designed not just to see stars, but to glimpse the very fabric of the cosmos. Now, imagine the thrill of discovering something that changes everything we thought we knew about that boundless expanse. This is exactly what happened with our pioneering scientists, the curious minds who first sensed the whispers of space's decay. In the early 21st century, a group of physicists, driven by an insatiable curiosity, found themselves on the brink of a groundbreaking revelation. These were not just any scientists. They were the kind who looked at the night sky and saw more than just stars. They saw questions waiting to be answered. Among them were Dr. Elena Martinez and Dr. Arjun Patel, two visionary thinkers who dared to ask, what if space itself isn't as permanent as we believe? Their journey began in a state-of-the-art observatory nestled high in the Andes, where the air is thin and the stars shine with an otherworldly clarity. It was here, under a canopy of endless night, that they noticed anomalies, tiny, almost imperceptible disturbances in the positions of distant quasars. These quasars, often used as cosmic lighthouses due to their incredible brightness, were shifting in ways that defied explanation. At first, these shifts seemed like mere errors, perhaps a calibration issue with the telescope. But as the data piled up, the anomalies persisted. Intrigued, Dr. Martinez and Dr. Patel began to wonder, could these shifts be evidence of something much more profound, perhaps a sign that space itself was undergoing some form of decay? To understand the gravity of their discovery, imagine the tools at their disposal. Advanced spectrometers measured wavelengths with precision, while quantum sensors captured data at the subatomic level. This technology allowed them to peer deeper into the universe than ever before. It wasn't just about seeing further, it was about seeing differently, capturing the subtle fluctuations in spacetime that had gone unnoticed for so long. Their curiosity transformed into a relentless pursuit of knowledge. They began collaborating with international teams, pooling resources, and cross-referencing data from other observatories around the globe. This collective effort, powered by a shared sense of wonder, led to a startling breakthrough in understanding space's dynamic nature. What they discovered was a hint of a cosmic phenomenon that could rival the most profound events in the universe. It wasn't just about space expanding as we know it. It was about space itself changing, evolving in ways that could alter the very laws of physics. This revelation opened a Pandora's box of questions. What mechanisms could drive such decay? Is the universe we inhabit a stable environment, or are we living on borrowed time? But here's what most people don't know. This discovery wasn't just about the data. It was about a shift in perspective, a new way of looking at the cosmos that challenged everything we thought we understood. It was a humbling reminder of our place in the universe, a universe that continues to surprise us with its mysteries. As they delved deeper, the enormity of their findings began to unfold. They realized that if space can decay, it might not be the timeless, unchanging entity we once believed it to be. This idea shook the foundation of cosmology, prompting a re-evaluation of existing theories and sparking debates among scientists worldwide. The implications were vast and complex. If space is decaying, what does that mean for the future of the universe? Could this be linked to other cosmic phenomena, like dark energy or the elusive nature of time itself? Each question led to another, creating a web of mystery that both fascinated and terrified those brave enough to explore it. In the spirit of scientific inquiry, Dr. Martinez and Dr. Patel didn't stop at questions. They sought answers, pushing the boundaries of technology and theory. Their work inspired a new generation of physicists, astronomers, and thinkers, all eager to unravel the secrets of a universe that seems to be more alive than we ever imagined. These early pioneers taught us that discovery is not just about finding answers, but about embracing the unknown. It's about standing at the edge of the abyss and daring to look over, knowing that what you find might change you forever. So, as you ponder the vastness of space and the possibility of its decay, consider this. What other secrets does the universe hold, waiting for those bold enough to seek them? This moment of discovery is just the beginning, a glimpse into the unknown that beckons us to explore further, deeper, and with an ever-open mind. Imagine a universe where the fundamental laws of physics are not as unyielding as we once thought. A universe where the very fabric of space, the stage for all cosmic events, is unraveling. This isn't just a plot twist in a science fiction novel. It's a scientific shockwave challenging everything we know. As we begin this section, I want you to picture the implications of such a reality. It's a scenario that's as mind-bending as it is unsettling. Why does this concept of decaying space challenge fundamental laws of physics? Well, to begin with, the laws of physics, as we understand them, are built on the assumption that space itself is a constant, a stable backdrop to the unfolding of time and events. Think of it as the sturdy canvas upon which the masterpiece of the universe is painted. Now, imagine if that canvas started to disintegrate. What happens to the painting? What happens to the laws that govern the colors and shapes on that canvas? It's a notion that rattles the very foundations of scientific understanding. Let's delve deeper into the skepticism that initially greeted the idea. When early whispers of decaying space emerged, the scientific community was, understandably, in disbelief. How could something so fundamental and assumed to be eternal, like space, possibly decay? It seemed to defy logic, and many scientists were quick to dismiss it as a theoretical anomaly rather than a real possibility. After all, space was supposed to be the ultimate constant, the reliable framework within which galaxies, stars, and planets dance their cosmic dance. Yet, as history has shown, science thrives on challenges to the status quo. It was this very disbelief that fueled rigorous investigation and debate. Researchers began scrutinizing data from telescopes and particle detectors, looking for patterns or anomalies that could either support or debunk this radical idea. They pored over cosmic background radiation, the afterglow of the Big Bang, for any signs that space might be less stable than previously thought. The implications of decaying space are profound. reaching far beyond mere scientific curiosity. If space can decay, then our understanding of the universe's past, present, and future must be re-evaluated. It raises questions about the fate of everything within that space, including us. Could the universe end not with a bang, but with a gradual unraveling of the very fabric that holds it together? It's a startling possibility that forces us to reconsider our place in the cosmos. Now let's pause for a moment and think about what this means for our understanding of the universe itself. If space is not the immutable constant we believed it to be, then what else might we have gotten wrong? The decay of space could mean that the constants we hold dear, like the speed of light or gravitational force, are more variable than once thought. It challenges everything from Einstein's theories of relativity to our understanding of quantum mechanics. But here's what most people don't know. This isn't just a theoretical exercise. The potential decay of space has real-world implications for technology, navigation, and even communication systems that rely on the consistency of space-time. Imagine a world where GPS systems become unreliable because the fabric of space itself is shifting. It's a scenario that sounds straight out of a dystopian future, yet it's a possibility we must consider. As we explore this further, we'll uncover the deeper layers of this mystery. We'll look at the data and theories that scientists are using to try and make sense of this phenomenon. And we'll delve into the philosophical implications of a universe where the ground beneath our cosmic feet is not as solid as we thought. Stay tuned as we continue to unravel this enigma, challenging our understanding of reality and pushing the boundaries of what we know about the universe. There's more to discover, and as we delve deeper into the scientific shockwave of decaying space, we'll find that the universe has more surprises up its sleeve. Imagine you're an astronomer, gazing up at the night sky through a telescope unlike any other. It's not just a window into the stars. It's a tool designed to peer into the very essence of our universe. Now, picture the excitement, the thrill, as you uncover patterns that defy everything you thought you understood about the cosmos. This is where our journey begins, into the heart of a mystery that could redefine the very fabric of reality. The instruments used to gather data on space decay are as varied as they are sophisticated. Think of telescopes, not just the kind you might find in an observatory, but powerful space-based instruments like the Hubble Space Telescope or the more recent James Webb Telescope. These marvels of engineering allow us to see light from galaxies billions of light years away, offering glimpses into the universe's distant past. But it's not just about seeing. Satellites equipped with sensors measure cosmic microwave background radiation, the afterglow of the Big Bang. This radiation is like a fingerprint of the universe, a map that can reveal changes in the fabric of space itself. Then there are particle detectors nestled in underground laboratories, capturing elusive neutrinos that pass through Earth by the billions every second. These tiny particles, nearly massless, can carry information from the farthest reaches of the cosmos. Now, imagine scientists poring over reams of data, eyes fixed on computer screens filled with graphs and charts. They're searching for anomalies, patterns that don't fit the existing models. And then they find them. Tiny discrepancies in the cosmic microwave background, subtle shifts in the positions of distant galaxies, and unexpected variations in the behavior of neutrinos. Each anomaly is a clue, a piece of a puzzle that suggests something is amiss. The first signs that something was wrong weren't headline-grabbing discoveries. Instead, they were whispers in the data, anomalies so subtle they were almost dismissed as errors. But as more evidence accumulated, a picture began to form. The anomalies weren't just noise, they were patterns, repeated across different observations and experiments. Something was happening in the vastness of space, something that couldn't be explained by our current understanding of physics. Consider the cosmic microwave background radiation. It's supposed to be uniform, a smooth glow left over from the Big Bang. Yet scientists began noticing tiny fluctuations, ripples that suggested changes in the very structure of space. It was as if the fabric of the universe was being stretched, pulled apart at the seams. In tandem, astronomers observed distant galaxies behaving strangely. Instead of moving predictably according to known gravitational forces, their paths suggested an unseen influence. Was it dark matter, an unknown form of mass? Or could it be something even more profound, like space itself starting to decay? The anomalies didn't stop there. Particle physicists noticed that neutrinos, those ghostly particles, were behaving in unexpected ways. Their interactions hinted at changes in the fundamental forces governing the universe. It was as though the rules of nature were starting to shift, ever so slightly, but enough to raise eyebrows across the scientific community. As you delve deeper into this mystery, you can't help but wonder, what does it all mean? If space itself is beginning to decay, what implications does that have for our understanding of reality? How do you reconcile these observations with the laws of physics that have stood for centuries? But here's what most people don't know. The universe is not static. It's a dynamic, evolving entity, constantly changing and challenging our perceptions. And while the idea of space decay may seem daunting, it's also an opportunity to push the boundaries of human knowledge, to explore new theories, and to redefine what we know about the cosmos. So, what's next? Scientists are racing against time, developing new models and theories to explain these anomalies. They're testing the limits of Einstein's theory of relativity, exploring concepts like dark energy and the multiverse. Could these be the keys to understanding the mystery of space decay? This journey into the unknown is not just a scientific endeavor, it's a philosophical one. It challenges our place in the universe, our understanding of time and space, and even the nature of existence itself. And as we continue to gather evidence, one thing is certain. The cosmos still holds many secrets waiting to be uncovered. As you contemplate these questions, remember that every discovery starts with curiosity. The drive to understand, to explore, and to seek answers to the mysteries of the universe is what makes us human. And while the concept of space decay might seem like a daunting puzzle, it's also a testament to the boundless potential of human ingenuity and imagination. As we peer into the cosmos, we're not just looking for answers, we're discovering new ways to see our place in the vastness of the universe. Imagine this: the universe, vast and silent, suddenly begins to murmur. At first it's a whisper, a ripple barely detectable, like the distant hum of a tuning fork. But with each passing moment, the murmur grows louder, more insistent. It's as if the cosmos itself is trying to tell us something profound and unsettling. This is the mystery we find ourselves in today, the universe's silent scream. Think about how each new discovery in space can feel like peeling away layers of an onion, only to find more layers beneath. Recently, scientists have noticed behaviors in cosmic structures that are nothing short of baffling. Galaxies that should be drifting apart at predictable rates are behaving unpredictably, almost as if they're dancing to a different tune. And it's not just galaxies. Entire clusters of stars exhibit erratic motions that defy the forces we thought governed them. Let's break this down a bit. Imagine you're watching a ballet, where every dancer has rehearsed their moves to perfection. But suddenly, one dancer breaks away, performing an unpredictable solo. At first, you might think it's part of the show, but soon, more dancers join in, each one moving in ways that make no sense to the narrative you were following. That's what's happening out there in the cosmos right now. Scientists have been scratching their heads, trying to make sense of these unexpected behaviors. Could it be that the very fabric of space is starting to decay? If space itself begins to unravel, how would that affect everything within it? Picture a tapestry slowly coming apart. Each thread represents a galaxy, a star, or even a planet. As the threads loosen, they drift, no longer held in place by the weave of the tapestry. But here's what most people don't know. The implications of space decay could be monumental. It might not just be a local phenomenon, but a precursor to a cosmic event on an unimaginable scale. If space itself is decaying, what happens to the laws of physics as we know them? Could gravity, electromagnetism, and even time be affected? It's like finding a crack in a dam. At first, it's just a trickle, but eventually the entire structure could give way. You might wonder if these observations are just anomalies, quirks in data that can be explained away. But the more we look, the more consistent these patterns become. It's as if the universe has been whispering to us all along, and we're only now starting to listen. Take, for instance, the phenomenon of dark energy. Scientists have long known that it plays a major role in the expansion of the universe. But what if dark energy is not just pushing galaxies apart, but is also a signal of space itself beginning to unravel? What if this mysterious force is the universe's way of adapting to a new phase, a phase we barely understand? This isn't just speculative thought. Theories like the false vacuum decay propose that our universe could be in a metastable state, teetering on the edge of a true vacuum. If this were true, a tiny fluctuation could cause the universe to collapse into a new state, fundamentally altering the cosmos. However, it's crucial to remember that science is all about testing these ideas. Researchers are using cutting-edge technology, like the Large Hadron Collider and advanced space telescopes, to gather more data. They're looking for clues in the cosmic microwave background, the afterglow of the Big Bang, hoping to find patterns that might reveal the universe's secrets. As you think about these possibilities, consider what they mean for us. If space itself is changing, how do we adapt our understanding of the universe? Does it force us to reconsider our place in the cosmos? Maybe this silent scream is a call to action, urging us to explore further, to listen more closely. In the end, the universe is a vast, mysterious entity, full of surprises. Each discovery, each anomaly, is like a piece of a puzzle, waiting to be placed in the grand picture of existence. And as we delve deeper into these mysteries, remember that each question we answer leads to even more questions, each more intriguing than the last. So, what do you think? Could we be on the brink of a cosmic revelation? Or is this just another chapter in the endless story of the universe? Share your thoughts and theories in the comments below. Let's keep this conversation going, because the universe's silent scream is something we can't afford to ignore. Picture this. You're standing on the edge of a cliff, staring into the infinite abyss of space. But what if I told you that the very fabric of this seemingly endless expanse could unravel? Today, we're diving into the mysterious realm where science meets imagination, exploring what happens when space itself begins to decay. Now, you might wonder, what does it even mean for space to decay? Let's start with some of the leading scientific theories. Imagine the universe as a massive quilt, each patch representing different forces and particles. This quilt is held together by quantum fields, invisible forces that govern the behavior of every atom and molecule. Quantum fields are the unseen architects of the cosmos, fundamentally shaping the universe's structure. But here's where it gets intriguing. Some scientists speculate that these fields might not be as stable as we once thought. Take the concept of cosmic inflation, for instance. Imagine the universe as a balloon and inflation as the puff of air that turned it from a speck into the vast cosmos we see today. During this rapid expansion, quantum fluctuations, tiny, random variations, occurred and left imprints on the universe's structure. These fluctuations could be the key to understanding space decay. They suggest that space isn't just sitting idly by, but is continually influenced by these quantum ripples. But here's what most people don't know. These fluctuations might lead to something called a false vacuum decay. In simple terms, it's like the universe is trapped in a state that's not entirely stable, like a ball resting on a hilltop, just waiting for the slightest nudge to roll into a more stable valley. If such a transition were to happen, the fundamental nature of everything could change in an instant. This idea is both fascinating and terrifying. Now let's bring in another intriguing concept, the multiverse theory. Imagine our universe as just one bubble in a vast ocean of universes, each with its own laws of physics. Some scientists propose that if space begins to decay, it could mean that our universe is transitioning to a state more like one of these other bubbles. This idea stretches the imagination, blending scientific theory with a hint of science fiction. But it opens up a universe of possibilities, quite literally. Why does this matter to you? Because understanding space decay could redefine our place in the cosmos. It challenges everything we think we know about reality. It's like realizing the ground beneath your feet isn't as solid as it seems. This is why scientists are on a relentless quest to uncover the truth. Let's delve deeper into some speculative ideas. Consider the possibility that space decay could create new forms of matter or even new dimensions. Imagine a world where the laws of physics are rewritten. This isn't just theoretical musing. It's grounded in the math of quantum mechanics and general relativity. These theories hint that space and time are not as rigid as they appear. Here's an engaging twist. While scientific theories provide a structured framework, they also invite wild speculation. What if decaying space could lead to phenomena like time travel or teleportation? While these are the stuff of science fiction, they encourage us to think beyond conventional limits. Think about black holes, the mysterious cosmic giants that are known for their insatiable appetite for everything, including light. Some theorists suggest that black holes might play a role in space decay. As they consume matter, they might also influence the stability of space around them. It's a tantalizing idea that blurs the line between destruction and creation. Now, let's explore what ongoing research is doing to test these theories. Scientists are using cutting-edge technology like particle colliders and space telescopes to probe the very fabric of space. They're hunting for evidence of vacuum decay by looking for anomalies in cosmic radiation or unusual particle interactions. Imagine these tools as cosmic detectives, piecing together clues from the universe's past and present. But here's a captivating thought. While technology advances, so does our understanding of what's possible. As we gather more data, we might discover that our current theories are just the tip of the iceberg. This is the beauty of science. It's an ever-evolving story. What do you think? Could the decay of space open doors to new realities, or are we merely scratching the surface of a cosmic enigma? Your thoughts and comments are not just welcome, they're essential to this unfolding narrative. As we wrap up this section, remember that the mystery of space decay is a dance between the known and the unknown. It's a reminder of the universe's complexity and our endless curiosity. So stay tuned as we continue to unravel the secrets of the cosmos, where each answer only leads to more questions. Picture yourself gazing up at the night sky, a vast tapestry of stars stretching beyond imagination. It's a scene that's both familiar and awe-inspiring. But beneath this serene canvas lies an intricate web of scientific marvels, a hidden world that scientists are dedicated to exploring. Today, we're diving deep into the tools and missions that unlock the mysteries of space decay, uncovering the secrets that the cosmos holds. Let's kick things off with telescopes, those gigantic eyes that peer into the universe's most distant corners. Telescopes, both on Earth and in space, serve as our primary means to observe the cosmos. Take the Hubble Space Telescope, for instance. Launched in 1990, Hubble has been pivotal in expanding our understanding of the universe. It's like a time machine, allowing us to see galaxies as they were billions of years ago. Imagine peering through a window into the past, witnessing the universe's history unfold. But here's something you might not know. The James Webb Space Telescope, Hubble's successor, is set to revolutionize our view even further. With its advanced infrared capabilities, it can see through cosmic dust, unveiling regions of space previously hidden from our gaze. Scientists hope to use Webb to explore phenomena like space decay, diving into the mysterious processes that could influence the very fabric of space itself. Now let's shift our gaze to satellites. These silent sentinels orbiting our planet are crucial for gathering data about space and cosmic events. The European Space Agency's Gaia satellite is a prime example. It's charting a three-dimensional map of the Milky Way, offering insights into the galaxy's composition, formation, and evolution. By understanding these cosmic structures, we inch closer to unveiling the mysteries of space decay. Then there are the particle detectors, the unsung heroes of space exploration. Located both underground and in space, these detectors capture elusive particles that could hold the key to understanding dark matter and energy, central elements in the study of space decay. The Large Hadron Collider, LHC, at CERN, is the world's largest and most powerful particle accelerator. It smashes particles together at nearly the speed of light, unraveling the building blocks of the universe. Through such experiments, scientists hope to detect evidence of processes that might signify the decay of space. But let's not forget the groundbreaking missions that have paved the way for our current explorations. The Wilkinson Microwave Anisotropy Probe, WMAP, mapped the cosmic microwave background radiation, providing a snapshot of the universe shortly after the Big Bang. This mission transformed our understanding of the universe's age, composition, and development. It's like piecing together a cosmic jigsaw puzzle, where each piece brings us closer to the bigger picture. And speaking of transformative missions, the Planck satellite, which succeeded WMAP, took these studies even further. It offered the most precise measurements of the cosmic microwave background, refining our understanding of the universe's infancy. By analyzing these ancient light patterns, scientists can infer details about the universe's expansion and potential space decay scenarios. As we delve deeper, it's essential to highlight the groundbreaking LISA Pathfinder mission. It tested technologies for detecting gravitational waves, ripples in spacetime caused by massive cosmic events. Understanding these waves is crucial in studying space decay, as they provide insights into the dynamics of the universe's expansion. Imagine the universe like a vast ocean with gravitational waves as the ripples on its surface. By studying these ripples, we can infer what lies beneath. So, what do scientists hope to uncover with all these tools and missions? At the heart of it lies a quest to understand the fundamental nature of space and time. By studying space decay, researchers aim to unlock secrets about the universe's origin, evolution, and ultimate fate. It's a journey into the unknown, where each discovery opens new questions, pushing the boundaries of human knowledge. But here's something fascinating. The concept of space decay challenges our understanding of reality itself. It hints at a universe that's dynamic and ever-changing, a cosmic dance where the rules are still being written. This idea not only fuels scientific inquiry, but also sparks philosophical debates. What does it mean for our perception of reality if space itself is subject to change? And here's what most people don't know. These scientific endeavors are not just about understanding the cosmos. They have practical implications too. The technologies developed for space exploration often find applications here on Earth, from medical imaging to communication systems. It's a testament to the interconnectedness of science, where discoveries in one field ripple across others, much like the gravitational waves we seek to understand. Now, imagine you're part of this cosmic journey, a detective piecing together clues scattered across the universe. Each mission, each observation is a step closer to unraveling the mystery of space decay. It's an exhilarating pursuit, where the stakes are nothing less than our understanding of the universe itself. As we continue on this journey, remember that every question answered leads to new mysteries to explore. The universe is vast, and its secrets are endless. But with each tool, each mission, and each discovery, we inch closer to understanding the grand tapestry of existence. So, what's next in this cosmic quest? As new telescopes and missions are launched, the horizon of discovery expands. Future projects like the Square Kilometre Array, SKA, promise unprecedented insights into the universe's structure and evolution. With its vast network of radio telescopes, SKA will probe deeper into cosmic phenomena, potentially shedding light on the mechanisms behind space decay. And as we gaze into the future, the question remains, what will we uncover next? The universe is a vast, mysterious place, and we've only just begun to scratch the surface. With each new tool and mission, we peel back another layer of the cosmic onion, revealing more of the universe's secrets. As we wrap up this exploration of the tools and missions unraveling space decay, let's pause and reflect. We're part of a grand adventure, a journey into the unknown that challenges our understanding and ignites our imagination. It's a reminder of the boundless curiosity that drives us to explore, to seek answers, and to embrace the mysteries of the universe. So, join us as we continue this journey, delving deeper into the cosmos and uncovering the secrets that lie within. Who knows what discoveries await on the horizon? After all, the universe is full of surprises, and the adventure is just beginning. Imagine for a moment that the universe is like a grand cosmic dance. You're part of this vast, swirling ballet, where every star and galaxy moves to an unseen rhythm. But what if the stage itself, the very space that hosts this majestic performance, begins to change? This is where dark energy enters our story, a mysterious force that's as enigmatic as it is powerful. It's like a cosmic puppeteer pulling the strings of the universe in ways we're only beginning to understand. You might be wondering, what exactly is dark energy? In simple terms, it's a form of energy that makes up about 68% of the universe. But here's the kicker. We can't see it, and we don't really know what it is. It's like trying to describe the wind by only watching the leaves rustle. We know it's there because of its profound effects on the cosmos, particularly on the ever-expanding universe. Let's dive deeper into how dark energy might be influencing space itself. Picture this. The universe is expanding, and it's doing so at an accelerating pace. This acceleration is one of the most groundbreaking discoveries in modern cosmology, and dark energy is thought to be the driving force behind it. Imagine blowing up a balloon. The more you inflate it, the more the surface stretches. Now apply this analogy to our universe. As space expands, galaxies drift further apart. But unlike a balloon, there's no outer boundary, no end. It's infinite, stretching endlessly. Dark energy acts like an invisible hand, pushing everything apart. But here's where it gets even more intriguing. What if dark energy isn't just pushing things away? What if it's also responsible for the potential decay of space itself? You see, as space expands, its very fabric might be thinning out, like a piece of elastic stretched to its limit. This leads us to consider the possibility that space could eventually lose its structural integrity. Now, let's talk about the implications of dark energy's role in this cosmic puzzle. If space is indeed decaying, it could have mind-boggling consequences. Imagine if, one day, the bonds holding galaxies together begin to weaken. Stars could drift off into the void, planets might lose their orbits, and the universe as we know it could unravel. It's a scenario straight out of science fiction, yet it's grounded in very real science. Here's something most people don't know. Dark energy might not be constant. Some theories suggest it could change over time. If that's true, it means the rate at which space decays might also change, adding another layer of complexity to this cosmic conundrum. It's like trying to solve a puzzle where the pieces keep shifting. To really grasp the enormity of dark energy's influence, let's consider a few real-world analogies. Think of it as a silent orchestra conductor. We don't see the conductor, but we hear the music change tempo and mood. Similarly, dark energy adjusts the tempo of the universe's expansion. Or imagine a pot of water on a stove. As you turn up the heat, the water begins to boil more vigorously. Dark energy is like that heat, accelerating the expansion of space. But here's a common mistake to avoid. thinking of dark energy as a force like gravity or electromagnetism. It doesn't pull or push in the traditional sense. Instead, it operates on a cosmic scale, influencing the fabric of space itself. This unique characteristic makes it a fascinating subject of study and speculation. So, what's next in our journey to understand dark energy? Scientists are on a mission to decode its mysteries. They're using sophisticated tools, from space telescopes to particle detectors, to gather clues. The goal is to measure dark energy's properties more accurately and understand its behavior over time. These efforts could potentially reveal whether space is indeed decaying and what that means for the future of the universe. As we reflect on dark energy's role in the cosmos, we're left with profound questions. What does this mean for our understanding of reality? Does it change our perception of time, space, and existence? Dark energy challenges us to rethink the universe's dynamics and our place within it. It's a reminder of how much there is yet to discover, and how every answer leads to new questions. In the end, dark energy is more than just a scientific curiosity. It's a cosmic enigma that invites us to explore, question, and wonder. It's a testament to the universe's complexity and beauty, urging us to look beyond the stars and into the very essence of space itself. So next time you gaze up at the night sky, remember, it's not just a sea of stars you're seeing. It's a universe in motion, with dark energy quietly choreographing its grand performance. And as we continue to unravel its secrets, who knows what other mysteries we might uncover. Imagine standing on the edge of a great unknown, where the familiar rules of the universe start to blur and twist. What if the very fabric of space, the stage upon which the cosmic dance unfolds, began to unravel? This isn't just science fiction. It's a possibility grounded in the profound insights of Albert Einstein, whose theories of relativity redefined our understanding of space and time. But how do these theories intersect with the enigmatic concept of decaying space? And what does this mean for the future of our universe? Einstein's theories are like a pair of spectacles, revealing the hidden connections between space, time, and gravity. Let's dive into the basics. Imagine space as a vast, stretchy fabric. This fabric isn't static. It bends and warps around objects with mass, like a trampoline sagging under the weight of a bowling ball. This visualization is central to Einstein's general theory of relativity. It suggests that massive objects like planets and stars distort the space around them, and this distortion is what we perceive as gravity. Now, why should you care about this? Because it's the key to understanding how the universe works at its most fundamental level. Picture this. If space itself started to decay, what would happen to the objects embedded within it? Would they drift apart or collapse into chaos? Here's where things get fascinating. Einstein's equations allow us to imagine not just a static universe, but a dynamic one. A universe that can expand, contract, or even tear itself apart. This flexibility gives us a framework to explore what might happen if space began to decay. But how do we know space can even change in such a dramatic way? This is where the challenges of modern physics come into play. Einstein's theories have been tested and confirmed countless times, from the bending of light around the sun to the detection of gravitational waves. Yet when we talk about decaying space, we're venturing into uncharted territory. It's like exploring a new planet, uncertain of what we'll find. Let's consider an analogy. Think of space as a loaf of bread and galaxies as raisins within it. As the bread bakes, it expands, and the raisins move further apart. But what if this bread began to crumble? The structure that holds the raisins in place would weaken. Similarly, if space decays, the very structure that holds galaxies together could disintegrate. This leads us to a crucial question. What evidence do we have that space might decay? While we don't have direct evidence, clues come from the realm of quantum mechanics, the physics of the very small. At this scale, particles can pop in and out of existence, borrowing energy from the vacuum of space itself. This suggests that space isn't as empty as it seems. It's a frothy sea of potential. Could this frothy sea cause space to decay? It's a possibility that intrigues physicists. If true, it would mean that the vacuum of space is unstable, like a house of cards waiting for the right nudge to collapse. Now, let's talk about the opportunities this presents. If space can decay, it could lead to revolutionary insights about the universe. It might help solve some of the biggest puzzles in physics, like the nature of dark energy or the fate of the universe. Understanding decaying space could unlock new technologies or even new ways to travel through the cosmos. But here's where it gets tricky. Modern physics relies heavily on Einstein's theories, yet they don't fully explain everything. The intersection of relativity with quantum mechanics is a landscape fraught with paradoxes and mysteries. It's like trying to fit a square peg into a round hole. This tension is both a challenge and an opportunity. It pushes scientists to explore new theories that might bridge the gap, such as string theory or quantum gravity. Imagine the implications if we could unite these theories into a single framework. It would be like finding the Rosetta Stone for the universe, translating the language of the cosmos into terms we can fully understand. This pursuit is one of the grand challenges of modern physics, and you're witnessing it unfold in real time. But there's more to this story. As you ponder the vastness of space and the possibility of its decay, consider the philosophical implications. What does it mean for us, tiny beings on a small planet, if the universe itself is unstable? Does it change how we view our place in the cosmos? Engage with this idea. If space were to decay, it could reshape the very essence of reality. It challenges us to think beyond our everyday experiences and consider the universe as a living, evolving entity. This idea is both thrilling and humbling. It reminds us that science isn't just about facts and figures. It's about exploring the unknown, asking bold questions, and embracing the mysteries that lie beyond our current understanding. So, as you contemplate Einstein's legacy and the possibility of decaying space, remember that you're part of a larger journey, a journey that seeks to unravel the secrets of the universe, one discovery at a time. And who knows, perhaps one day you'll be the one to uncover the next great mystery of the cosmos. Until then, keep looking up, keep asking questions, and keep exploring the infinite possibilities of the universe. And here's a thought to ponder. If space itself is a canvas, ever-changing and dynamic, what picture will it paint next? What stories will it tell? What secrets will it reveal? The answers might just be waiting in the stars, ready for those daring enough to seek them. Imagine for a moment the universe as an immense balloon. It's not just any balloon, though. It's one that keeps growing, expanding beyond what we can easily comprehend. This idea of expansion is crucial to understanding cosmic inflation, a theory that takes us back to the universe's earliest moments. Picture the universe as a tiny speck, smaller than an atom, suddenly ballooning to an astronomical size in a fraction of a second. That's cosmic inflation for you, a rapid expansion that sets the stage for everything we see today, and perhaps everything we still don't understand. You might be wondering why this matters when talking about space decay. Well, inflation doesn't just help us understand how the universe began. It also offers clues about how it might continue to evolve, and perhaps even decay. In the seconds after the Big Bang, the universe underwent this rapid inflation, smoothing out any irregularities and setting a uniform stage for the cosmic dance of galaxies, stars, and planets. But here's the kicker. The forces that drove this inflation are still shrouded in mystery. What if these forces are, even now, laying the groundwork for space itself to decay? To grasp this better, let's dive into how inflation has shaped our understanding of the cosmos. Inflation explains why the universe looks the way it does, so uniform and flat on a grand scale. Imagine a piece of paper. It might seem flat to the naked eye, but look closer and you'll find tiny imperfections. Inflation smooths out the cosmic paper, stretching it until those imperfections are barely noticeable. This smoothing effect explains why the cosmic microwave background, the afterglow of the Big Bang, shows such remarkable uniformity. But inflation isn't just about the past. It has profound implications for the future. Scientists believe that understanding inflation could unlock secrets about the ultimate fate of the universe. Will it keep expanding forever? Or will it slow down and collapse in on itself? Or, more intriguingly, could the very fabric of space begin to unravel? Here's where things get even more fascinating. Inflationary theory suggests that the universe could be part of a multiverse, a vast collection of universes, each with its own rules and constants. If true, this raises profound questions about our universe's stability. Could a neighboring universe influence ours? Could the decay of space in one universe trigger a cascade of changes in others? Now, let's consider the potential signs of space decay. If space were to start decaying, we might see it first in the behavior of distant galaxies. They could start moving in unexpected ways, or the light from them could shift in patterns we don't currently understand. Inflationary theory suggests that such changes would be subtle at first, possibly even undetectable with current technology. But as our instruments become more sophisticated, we might start to see hints of this decay. This brings us to an intriguing question. Could the same forces that sparked inflation also be responsible for space decay? Some physicists propose that a field, much like the one that drove inflation, could exist, a field that might one day lead to the decay of space itself. Imagine it like a ticking cosmic clock, slowly counting down to a moment when the universe, as we know it, begins to change in fundamental ways. As you ponder this, consider the implications for our understanding of reality. If space can decay, what else might be possible? Could time itself unravel? Could the constants of nature, like the speed of light, change overnight? These are not just academic questions. They strike at the heart of what it means to exist in a universe governed by laws we thought unchanging. So, what does this mean for us here on our small blue planet? For now, these questions remain in the realm of theoretical physics, far removed from our daily lives. But as we continue to explore and understand the universe, we edge closer to answers that could reshape our understanding of existence itself. In the meantime, The journey to uncover these cosmic mysteries continues. Astronomers and physicists are using cutting-edge technology, telescopes that peer further into space and time than ever before, and particle colliders that recreate the conditions of the early universe to test these theories. Each discovery, each piece of data, brings us one step closer to understanding whether space decay is a distant possibility or an imminent reality. And as we stand on the brink of these discoveries, we are reminded of the immense beauty and complexity of the universe. It's a reminder that while we have come a long way in understanding the cosmos, there is still so much that remains beyond our grasp. Yet it's this very mystery that drives us to explore, to seek answers, and to wonder what lies beyond the horizon of our current knowledge. So, what do you think? Could inflation be the key to unlocking the mysteries of space decay? Or are we only scratching the surface of a much deeper cosmic mystery? Let us know your thoughts in the comments below. And remember, in the vast dance of the universe, every question leads to another, and every answer is just the beginning of a new journey. Picture this, a world where the very fabric of space isn't just a passive backdrop to the cosmic story, but a dynamic, shifting entity open to the peculiarities of quantum mechanics. The idea that space itself could decay might sound like pure science fiction, yet it's a concept that some of the brightest minds in physics are beginning to explore. So, what happens when we dive into the quantum realms, where the micro meets the macro? Let's begin by delving into the quantum world, a realm so tiny and bizarre that it defies our everyday intuition. At this scale, the rules of classical physics give way to the strange dance of particles and waves. Quantum mechanics, the theory that governs this microscopic universe, introduces us to phenomena like superposition and entanglement, where particles can exist in multiple states at once or be mysteriously linked across vast distances. But how does this relate to the decay of space? Imagine space not as a static void, but rather as a seething, frothy ocean of quantum fields. These fields, invisible yet omnipresent, underpin everything from the air we breathe to the stars we gaze upon. Now, consider the possibility that these fields might ripple and fluctuate, causing what we perceive as space to change or even decay over time. This brings us to a fascinating notion: the interplay between quantum fields and cosmic structures. Quantum fields aren't just confined to small scales. They influence the grand tapestry of the cosmos in ways that are only beginning to be understood. For instance, the Higgs field, which gives particles their mass, permeates the universe. If such fields were to vary or shift, the consequences for space itself could be profound. But how does this quantum perspective provide insight into space decay? One potential breakthrough lies in the concept of vacuum decay. In quantum field theory, a vacuum isn't truly empty. It's a state filled with energy and potential. The universe might occupy a false vacuum, a precarious state that could transition to a true vacuum, triggering a catastrophic reconfiguration of space itself. It's a bit like a snow-covered mountain slope, seemingly stable, yet with the slightest disturbance, an avalanche could occur. Here's where the quantum world offers a surprising twist: the notion of tunneling. In quantum mechanics, particles can tunnel through barriers, achieving feats that would be impossible according to classical physics. This tunneling could, in theory, allow a region of false vacuum to spontaneously transform into a true vacuum, unleashing a ripple effect that propagates through space. But here's what most people don't know. This isn't just about destruction. Quantum mechanics also opens doors to understanding space's resilience and adaptability. Quantum entanglement, for example, might offer a mechanism for space to maintain coherence even as its underlying fields fluctuate. Imagine a cosmic safety net, woven from the threads of quantum connections, holding the fabric of space together. As we explore these realms, we're confronted with both awe and mystery. The potential breakthroughs in understanding space through quantum physics challenge us to rethink the nature of reality itself. It's a journey that blurs the lines between the known and the unknown, the possible and the impossible. Yet these ideas aren't just theoretical musings. They're being actively investigated with cutting-edge scientific tools. Particle accelerators like the Large Hadron Collider probe the quantum fields that compose our universe. Meanwhile, space telescopes peer into the depths of the cosmos, searching for clues about how quantum mechanics shapes the vastness of space. So, what can we take away from this quantum exploration? For one, it invites us to reconsider our place in the universe. If space itself is subject to decay, what does that mean for the future? It urges us to remain curious and open-minded, ready to embrace new paradigms that could redefine our understanding of the cosmos. As we wrap up this exploration, think about the questions that remain. Could quantum mechanics hold the key to preventing space decay? Or is it an inevitable part of cosmic evolution? How do these quantum mysteries relate to our daily lives? And what do they reveal about the universe's ultimate fate? In the end, the journey through the quantum realms is as much about discovery as it is about wonder. Each step we take peels back another layer of the cosmic onion, revealing a universe more intricate and interconnected than we ever imagined. And while we may not have all the answers, the pursuit of knowledge itself is a testament to the resilience and curiosity that define us as a species. So, what's next on this cosmic journey? Only time, and perhaps a bit of quantum magic, will tell. Imagine standing on the shores of a vast ocean, waves crashing endlessly at your feet, each one slightly different from the last. Now, imagine that ocean represents the universe, and those waves symbolize the constant changes happening all around us. When we talk about the decay of space, we're really diving into one of the most profound questions humanity has ever faced. What does it mean for us, for life, and for our understanding of existence if the very fabric of reality is shifting beneath us? For centuries, humans have gazed at the stars, wondering about our place in this grand cosmic dance. We've always assumed that the universe, while mysterious, was a stable backdrop to our lives. But what if it's not as unchanging as we thought? The idea that space itself could decay challenges everything we know. It's like finding out that your seemingly solid ground is actually a raft floating on a changing sea. This possibility forces us to reflect on our role in a universe that's alive with change. If space, that vast expanse holding everything we know, is not permanent, what does that mean for us? Suddenly, the questions we ask ourselves take on a new depth. Are we just cosmic wanderers, adrift in an ever-changing universe? Or is there more to our existence, something that connects us to this cosmic transformation? Let's take a step back and consider the philosophical implications. If space is decaying, it suggests a universe that's not only expanding, but evolving. It's a universe that may have a beginning and an end, raising existential questions about our purpose and the nature of time itself. Are we racing against a cosmic clock, or is our journey a part of a greater, unknowable destiny? Think about this. Every discovery about the universe has changed our perception of reality. When we realized Earth wasn't the center of the universe, it shifted our worldview. If space itself is changing, it suggests a universe that's more dynamic than we've ever imagined. This isn't just a scientific curiosity. It's a profound shift that touches every aspect of our understanding. But here's what most people don't know. This idea isn't just theoretical musings. It's rooted in real science, real observations. Physicists are using cutting-edge technology to study the cosmic microwave background radiation, looking for signs of decay. They're peering into the quantum world, where the rules are as strange as they are enlightening. And through these efforts, they're piecing together clues that could redefine our understanding of everything. Now, let's explore what this means for our everyday lives. In a universe where change is the only constant, adaptability becomes our greatest tool. Just as species evolve to survive, humanity must learn to embrace uncertainty, to thrive amid the unknown. This isn't a call to fear, but an invitation to explore, to push the boundaries of what we know and what we can become. Imagine a world where we embrace this cosmic evolution. What innovations might we achieve? What new philosophies might arise? By confronting the idea of a decaying universe, we're not just exploring the cosmos, we're exploring ourselves, our potential, and our place in the grand tapestry of existence. Let's not forget the emotional impact of these reflections. Pondering our place in an evolving universe can be both humbling and inspiring. It reminds us of our fragility, but also of our incredible capacity to learn, to adapt, and to dream. It challenges us to look beyond our daily lives and see the bigger picture. As we continue this journey of discovery, remember, the universe is not a static entity. It's a living, breathing cosmos, full of mysteries waiting to be unraveled. And in this cosmic dance, we are both observers and participants, shaping our destiny with every question we ask and every answer we seek. So, what's next for humanity in this ever-changing universe? How do we prepare for the unknown? These questions remain, urging us to explore further, to seek answers. And as we look to the stars, we keep asking, what will we discover next? What new wonders await in the vast, mysterious ocean of space? Imagine you're sitting under a starlit sky, the vast expanse above you a canvas of mystery and wonder. As you gaze up, it's easy to take for granted that the stars and galaxies are fixed in place, dancing to the eternal rhythm of the cosmos. But what if I told you that the very fabric of space, the invisible stage where all this cosmic drama unfolds, could decay? Sounds like a plot twist from a sci-fi movie, right? Yet, it's a topic that stirs up a lot of misconceptions. Let's dive into these misunderstandings and unravel the truth. First off, when we talk about space decaying, we're not suggesting that space will suddenly disappear into nothingness. One common misconception is that space decay means everything will just vanish. But here's the real scoop. Space decay refers to the idea that the properties of space, like a change in its energy state, could evolve over time. Think of it as space undergoing a kind of transformation, not an abrupt end. It's a subtle shift, much like the gradual fading of a sunset rather than turning off a light switch. This concept often gets tangled up with another idea: the expansion of the universe. Many people mix up space decay with the universe's expansion, assuming they're two sides of the same coin. But while the universe's expansion is like a balloon inflating, space decay could be more like the balloon's material changing over time. These are distinct processes, each with its own implications and mysteries to solve. Another point of confusion is the role of dark energy. Often dubbed as the force behind the universe's accelerated expansion, dark energy is sometimes mistaken as the cause of space decay. But here's the twist. While dark energy influences how space stretches, space decay could involve shifts at a more fundamental level, possibly tied to quantum fluctuations or changes in vacuum energy. It's like comparing the engine that drives a car with the changes happening in the car's fuel efficiency over time. They interact, but they're not the same thing. Now, let's clear up a big one. The idea that space decay is happening right now and we're doomed. This is more fiction than fact. Current scientific understanding suggests that if space decay is happening, it's likely on a timescale so vast that it stretches beyond our current horizon. It's a fascinating topic for sure, but not one to lose sleep over tonight. You might wonder, why all this confusion in the first place? Well, space decay is a complex topic, one that dances at the intersection of cosmology and quantum physics. And honestly, who wouldn't get a bit tangled up in the details when pondering such profound concepts? Understanding these complexities underscores the importance of scientific literacy. In a world bursting with information, distinguishing fact from fiction is a superpower. It empowers you to engage with these cosmic questions, not just as a curious observer, but as an informed participant in the great scientific conversation. So, what can you do to keep these misconceptions at bay? Dive deeper into scientific resources, explore credible articles, and keep asking questions. Curiosity is your best tool in navigating the universe's mysteries. Remember, science is not about having all the answers. It's about constantly reaching for them, one discovery at a time. As we venture further into this cosmic enigma, you'll see how space decay, if proven, could redefine our understanding of the universe. But for now, let these clarifications serve as a guide through the starry maze of misconceptions. And as you ponder these ideas, remember that every question you ask is a step closer to unraveling the mysteries of the cosmos. But here's what most people don't know. The implications of space decay could extend far beyond just the cosmic landscape. How might it shape our very understanding of reality? That's a story we're just beginning to tell. Stay tuned, because the universe still has many secrets to whisper. Imagine a world where the very fabric of space is unraveling. It sounds like the stuff of science fiction, doesn't it? But here's the twist. Scientists are already on the case, probing the mysteries of space decay through ambitious space missions. This isn't just a distant fantasy. It's happening right now, and it's reshaping our understanding of the universe. Let's dive into the specifics. Space missions are more than just sending rockets off into the unknown. They're about unraveling secrets that could redefine everything we know about space and time. Take the James Webb Space Telescope, for instance. This marvel of technology is peering deeper into the cosmos than ever before, capturing light from billions of years ago. But why does this matter to you? Because each image it sends back is a piece of a cosmic puzzle, a puzzle that might just reveal the first signs of space decay. You see, detecting space decay isn't straightforward. It requires cutting-edge technology and international collaboration. That's where global efforts come into play. Agencies like NASA, ESA, and Roscosmos are joining forces, pooling resources, and sharing knowledge. It's a planetary team-up to tackle one of the universe's most enigmatic riddles. Imagine a conference room filled with scientists from around the world, each speaking different languages but united by a common goal. It's a testament to what humanity can achieve when we work together. But let's not get ahead of ourselves. What could these missions uncover? Well, here's a tantalizing thought. What if space decay could explain the mysterious dark energy that's causing the universe to expand at an accelerating rate? Think about it. By understanding space decay, we might unlock the secrets of dark energy, a force that makes up about 68% of the universe. That's a potential game changer for both science and society. And here's where it gets even more intriguing. Imagine discovering that space decay could influence the fundamental constants of nature. The laws of physics, as we know them, might not be as constant as we thought. It's a mind-bending concept, isn't it? But if true, it could revolutionize our understanding of reality. This is the kind of discovery that keeps scientists up at night, pondering the implications. Now, let's talk about the impact on society. If we could harness the knowledge of space decay, it could lead to technological advancements we can scarcely imagine. Picture new forms of energy, revolutionary communication systems, or even breakthroughs in transportation. The possibilities are as vast as space itself. But before we get carried away, let's consider the challenges. Exploring space decay isn't without its hurdles. The technology required is immensely complex and costly. There are risks involved, and success is never guaranteed. Yet the potential rewards make these challenges worth facing. It's like climbing a mountain. The journey is difficult, but the view from the top is breathtaking. So, as we stand on the brink of these discoveries, you might wonder, what can you do? Stay curious, follow these missions, engage in discussions, and share your thoughts. Who knows? Your questions and ideas could inspire the next breakthrough. In the grand scheme of things, space exploration is a reminder of our place in the universe. It shows us that while we are small, our capacity for understanding and discovery is immense. As we continue to chart the unknown, each step forward is a testament to human ingenuity and curiosity. And here's a thought to ponder as we wrap up this section. What if the decay of space itself is just the beginning? What other secrets does the universe hold, waiting for us to uncover? The adventure is far from over, and with each new mission, we get closer to unlocking the mysteries of the cosmos. Are you ready to see what lies ahead? Imagine standing on the edge of a vast ocean where the horizon seems to stretch endlessly. Now, picture the universe as that ocean, an infinite expanse of mysteries waiting to be uncovered. This is the universe we inhabit, a place where every answer leads to a new question, every discovery a gateway to uncharted cosmic shores. But what truly drives us to explore this boundless frontier? Our quest for understanding is as old as humanity itself. It's a journey fueled by curiosity, by our innate desire to know more about the world and our place within it. When you gaze up at the night sky, you're looking at a testament to this endless pursuit, a universe filled with wonders that beckon to be understood. The idea of space itself decaying might sound like science fiction, but it opens up a philosophical portal. It challenges us to ponder not just the mechanics of our universe, but its very essence. What if the fabric of reality is more fragile than we ever imagined? What would that mean for everything we know? As we unravel the secrets of space decay, we find ourselves at the crossroads of science and philosophy. The universe is not just a collection of stars and galaxies, but a tapestry of stories, each thread a mystery waiting to unfold. And in every mystery, there's an opportunity to learn, to grow, and to redefine our understanding of reality. Think about this. The universe is expanding, constantly changing, much like our knowledge about it. Every satellite launched, every telescope aimed at the skies is a step toward peeling back the layers of this cosmic onion. But here's a thought that might surprise you. What if the more we learn, the less we truly know? The more questions we answer, the more questions arise. It's a paradox, a beautiful one, that keeps us moving forward. This relentless quest isn't just about the data or the theories. It's about the thrill of discovery. Imagine the excitement when scientists realized that the universe is not static, but expanding, or the awe when they discovered exoplanets orbiting distant stars, each one a potential cradle for life. These are not just scientific achievements, they're milestones in our journey to understand the infinite. But here's what most people don't know. The universe has a way of humbling us. Every time we think we've got it figured out, the cosmos throws in a cosmic curveball. Dark energy, dark matter, the possibility of multiverses. Each concept challenges our perceptions and pushes the boundaries of what we consider possible. So, what's the takeaway here? Stay curious. The universe is a playground of possibilities, and it's calling out to you. Whether you're a budding scientist, a stargazer, or simply someone who wonders what lies beyond the stars, your curiosity is the engine that drives this cosmic exploration. Imagine the future. Where might our quest for knowledge take us? New frontiers, new technologies, even new forms of understanding that we can't yet fathom. Each discovery is like a ripple in the ocean of space, spreading outwards, affecting everything it touches. This journey is far from over. In fact, it's only just beginning. With each passing day, we uncover more about the universe and, in turn, more about ourselves. We stand on the brink of discoveries that could redefine our understanding of time, space, and existence itself. As you ponder these mysteries, remember that the universe is not just out there. It's part of us. It's in every atom of your being, in every breath you take. We are quite literally made of stardust, connected to the cosmos in ways that are both profound and humbling. So, as we continue this journey, let's embrace the unknown with open minds and open hearts. Let's celebrate the questions, relish the mysteries, and cherish the endless quest for knowledge. Because, in the end, it's not just about finding answers. It's about discovering the questions that guide us toward the horizon of understanding. Stay curious, stay engaged, and keep looking up. The universe is waiting for you to explore its infinite possibilities.